we're going to speculate a bit about the future of 3D printing. We'll talk a little bit about what's going on currently and see what you're working on. But the broader picture, 10, 15, maybe even 20 years down the road, how is this going to grow? It's been exploding recently, and now it's gotten to a point where the price point's so low that anybody can have one.
Oh, yeah.
So let's go ahead and start talking about right now. What are you working on now, and how have things changed since you started with 3D printing?
So like you just said yourself, 3D printing is accelerating at such a rate that it's almost outpacing my imagination. It's pretty wild. Like when I started, I would say about 2 years ago, when I got my first 3D printer, it was an Ultimaker V1, and it basically looked like it was, built in a garage out of plywood, and, had some wires and shit on it. It looked like it had stepper motors out of a recycled soda machine. But, and it's funny because that's like what 3D printers were back then, right? And there was none of this go into Fry's Electronics or Best Buy and just buy one off the shelf. There was, even back then, MakerBot was just starting to, become the mainstream kind of face of 3D printing to the masses. But realistically, the only thing that you could print at the time was two materials. You either printed ABS, which was a toxic-ass plastic that you had to melt at really high temperatures, and if you were in the same room as it, you'd probably die. That's actually not true. I printed with ABS here before, but it gives you a wicked headache. So that was a big problem that they had to solve. So then they came out with a material called PLA, which I think stands for polylactic acid or something like that. It sounds really horrible. But the PLA has a much lower melting point, so you don't have to heat it up as much, and it literally smells like waffles. So that's like win-win, right? And it's technically a more rugged plastic than ABS is. It doesn't have as much flexibility to it, but it does crack if you put it under a massive amount of pressure. So now you've got a couple of options. Well, now fast forward a little bit. I've got my fourth 3D printer on the way now. Still all FDM, which are the filament type printers, but now the materials have been the game changer. The printers have stayed largely the same. They've gotten faster, they've gotten more stable, but they all still work basically like a glue gun. I mean, if you want to get down to brass tacks, it's a glue gun, and a stepper motor is just replacing the little guy you hire that does this, right? So so the materials are the game changer now. And now they've got materials like, here, I'll show you one thing right here. Here's a little mini-me. That's a little mini Barnacules. And this was actually 3D modeled by my Mini Factory. They sent this to me after meeting me at Maker Faire, and I thought it was a little creepy. I mean, God, the face that shows like that.
Hold on, did they actually take the time to model that out, or did they do like a scan of your face?
They literally modeled that from a couple of pictures they took of me, and they were just freelance pictures. They didn't have me against a backdrop or anything. So somebody 3D modeled that.
Somebody sat there for a long period of time making your face.
Yeah, I warped
a long period of time
making that sucker. But the thing about this right here is this is actually bronze, the metal. And so this is 80% bronze mixed with 20% plastic. So now they figured out how to create these composite materials that can still be extruded accurately. But now they contain metallic content. They have a copper material now that they I think is already out. They're working on a gold material. They even have structural materials like composites like carbon fiber and PLA mixtures and stuff like that. So every day it seems like I see some kind of new material, and chances are I probably have it in a pile over here in the corner of my room that I just haven't touched yet. But it's the materials that are really, really making leaps forward. The printers are staying largely the same. The resolutions are still around 100 microns. They've gotten a little bit faster, like I said, but there's a whole nother stage of 3D printers coming that'll be available to the public that are not FDM. And that's like, have you heard of stereolithography?
That'd probably be, yeah, I've heard of it, but I haven't, really gotten into it or anything. Wendell will probably know a little bit more about that than I know about it.
Wendell, were you there?
there was a Kickstarter for one of those printers, but I don't know what came of it. But it was one of those, and it used liquid resin as its setting material, which I thought was very efficient.
This is the cool thing about stereolithography printers is in conventional FDM printing like we have with the MakerBots and stuff like that and the Ultimakers, you basically have a platform, you draw a layer, you move it, you draw another layer, you move it, and you basically keep adding to that as you're going up. Well, the problem is you have to deal with things like overhangs and stuff like that. You have to basically print support material. You have to print basically lattice structures that you have to cut away if you have a design that's complicated and has overhanging parts, because gravity's kind of a bitch like that. So they've kind of dealt with that with some of these other technologies like stereolithography, where it's like you literally have a pool of resin. It's a liquid pool, and a laser draws on it, and then it drops it down into the pool a little bit, and then sweeps another layer of material over the top of it, and then lasers that and cures it, and it keeps building it, but it's actually being built in the liquid. So you can actually do a lot more without support material than you can with standard FDM. And they even have more advanced 3D printing than that. It's like Shapeways. You guys familiar with the Shapeways company?
Mm-hmm.
Okay, so Shapeways is basically like the industrial 3D printer guys that you can go to if you're like, you want the best of the best that 3D printing can do. And that's because they have machines that are like $1 million. These are machines you're not going to see in your house because, well, they're $1 million unless you're Bill Gates. And they need a lot of power. So again, you probably have to be Bill Gates. But the way that these machines work is they use powders. And they actually use a high-intensity laser to basically like melt and cure these powders. And so you can do infinitely complex shapes. Like, you don't have to have support material for anything. You can do floating, moving parts. I've seen them 3D print an entire motor that they literally took out, blew the dust out of the thing, and all the pistons and everything worked, the timing, the cams, everything. Printed is one piece, layer by layer. And that's what I'm hoping they find a way to bring that into the home. I want to start seeing the technology and the materials get refined down to the point where you can take this $1 million+ machine, which, you know, the FDM printers were like that 10 years ago. So hopefully in the future, that's what we're going to see coming into the house. And when that happens, you're going to have a whole bunch of new materials that you can print in, including metal, because they have metal powders that can also be cured by laser. And you're going to end up being able to make literally anything. I mean, I can't think of anything that you wouldn't be able to make. It's wild.
I think there's one of those companies that was selling, like, their new model just came out a few months ago, and they were 3D printing Colt 1911 firearms, the complete handgun, like basically assembled and ready to go. Not completely assembled. I think they had to add a spring or something, but the barrel rifling and the whole 9 yards was all 3D printed at one time, and that was from an Inconel powder.
Yep. No, and I've actually seen a machine capable of doing that type of print when I toured the Shapeways facility, because they literally take this metallic powder and they can even do titanium. That's the crazy thing. It's stupid expensive. I mean, to print a 1911 in titanium, between the power and the machine and everything, I mean, you might as well just go buy an entire gun store at that point. But the fact is, it can be done. You're literally a layer at a time creating this intricate mechanism, including, I mean, complex things like springs, right? I mean, you can print a metallic compressible spring, and that's mind-blowing. So the fact that they can do that today at the resolution that they can do, I mean, I think 10, 20 years down the road, are they going to be able to do this in a matter of seconds? You're going to walk up like a microwave and just, like a vending machine, and just punch in your little number of the item you want from Amazon.com, and it just, and farts it out the bottom, and you're good to go? I mean, is that the future of 3D printing?
I mean, it's really exciting, because even just conventional machining with titanium is even a little bit challenging because of the heat. Because, I mean, titanium will catch on fire if you're machining it CNC on a lathe. I mean, I've dealt with that a little bit, and it's like, we're going too fast. Our speeds and feeds are not right. Oh my God, something's on fire. And then all of a sudden the titanium is on fire, and that's very bad.
Oh wow! So it kind of shares some traits with like magnesium. I didn't know that. That's wild. I know the Germans love to make the old Volkswagen engines out of like what they use, like a magnesium composite in the blocks. And so if they got too hot, they would just burst into flames, and I guess you couldn't put them out because they just create thermal oxygen. Yep.
Same deal. It's like, oops, I accidentally created thermite.
Exactly. My water pump failed. We're melting down in the middle of 6th and 9th. Oops.
All right, I want to talk about the future in regards to electronics, because right now most of the things that you're printing, I mean, some people are actually out there printing PCBs, but by and large, most people are just printing either really handy, tools for the house, or just practical items, or even trinkets. So that's stuff like that. Do you think that we're going to see a big step forward in, I guess, like micro-circuit printing with the conductive inks and everything like that? So let's talk about that for a minute.
Well, honestly, I think right now the fact that they're already using 3D printers to actually print cellular constructs for organs, I mean, they're already 3D printing at the microscopic level. So I'd have to believe that printing circuitry is definitely in there, and I wouldn't be surprised if it isn't already happening. As far as that getting to a point where it outpaces conventional methods for creating those types of those types of circuits and being more cost effective, I think that's where you run into the problem right now, is that 3D printing, because of the materials and everything like that and the machines that you need to do it, is infinitely more expensive to create things in bulk. That's why they're largely only used for prototyping. But as far as being able to print like an electric circuit board, there's no reason why you couldn't, because you have materials that are non-conductive, you have materials that are conductive, you have the ability to put layers on top of layers, so you can lay insulation and lay more conductive pathways. So I think the only thing that's really holding us back is maybe resolution. I mean, obviously, to print a microprocessor that has like billions and billions of transistors on it, I'm not seeing like your home MakerBot V5 pulling that off anytime soon. But I definitely think that that's where prototyping is going. I mean, I wouldn't be the least bit surprised if companies aren't already using technology similar to that to like prototype small circuits and devices before they move them into some kind of mass production.
Right. So 20, 30 years down the road, how about this? Amazon Prime gives you a box called like the Prime printer, and maybe it's 20 nanometer by that time because we've moved on so much. And 20 nanometer, you can print like your home routers and that sort of thing. So what do you think? Think we'll be able to push a button and pay Amazon and get a home router printed?
Yeah, but here's the problem we're going to run into that one though, and it all comes back to our nice little video. Don't copy that floppy, right? It's like
right.
As soon as we come to the point where everybody has infinite manufacturing capabilities at your home, you're basically going to see your neighbors running around in their yard with rocket launchers, and people are going to be printing their own airplanes and putting them together in their garage. I'd have to imagine that if the technology gets to that point, it's going to be like severely regulated. I don't think that we'll ever have anything in our homes that we're allowed to be trusted and operate. If I can just go in there and be like, oh, hey, I'm on the piratebay.org downloading my Glock and my rocket launcher, my AR-15 and my AK. Oh, wait, 30 years in the future, my phaser, my plasma rifle.
Phaser.
Exactly.
Lightsaber.
So, lightsaber. Something tells me lightsaber isn't going to be the thing you're going to be printing when you see all your neighbors running around with like rocket launchers and heat-sinking missiles and stuff. But
I think with a real light. Go ahead.
No, go ahead.
I was saying with like a real lightsaber, there wouldn't be any like length restriction, So you could just turn on your lightsaber, and as long as there's not a mountain in the way.
That's what she said, buddy.
there's no length restriction.
Dial it to about 3 miles and just spin in a circle. Just listen to a little chaos.
Is that doing it for you?
Fire outside. Oh.
Yeah. So let's talk about regulation just a little bit, because that it could be. There's obviously going to have to be regulation because people are printing firearms and bazookas, and they'll print phasers, and when the cops show up, they'll be like, "Oh, I was just trying to roast my chicken because it was too big for the oven, so I printed a phaser." But no, you did not print a phaser to roast chicken. But there's going to be a lot of regulation. Do you think the regulation is going to stifle innovation? And also, do you think that there may be a time when we have always on DRM to make sure you're not printing, IP that's owned by some major corporation?
I think your first question, I think regulation is going to stifle innovation hugely. It always does. When has regulation ever helped innovation? It never does, right?
It's kind of the Wild West right now,
Yeah, it's like as soon as the government comes out and says, "Oh no, we're not going to play with stem cells anymore," then all you read about is other countries basically one step below creating human life and like curing every disease. So it's regulation. I think is ultimately going to screw innovation. But is it necessary? Probably, because you're always going to have people like me that are going to be like, "Wow, I wonder if I can print that." And the next thing you know, I got a nuclear reactor in my garage and I'm running away screaming from it and calling 911. It's going to happen. Regulation is absolutely going to happen. As far as the always-on DRM thing, that's a tricky one. Because here's what I hate about the always-on DRM, and I don't think they're going to solve this problem in the next 30 years or the next 100 years for that matter. And that is, it's never always on. You're always going to have some kind of infrastructure problem or something that's going to stifle your ability to authenticate, and then all of a sudden you can't 3D print your food for your family anymore. You can't 3D print the batteries for your car. I mean, there's always going to be something there that's going to screw you. And once we get to that point, we're going to be so heavily dependent on the technology. Because think about it. I mean, you watch sci-fi, right? And you see the food replicators, right? It's like, they can replicate weapons, but you're not allowed to. It can, but you're not allowed to, And it can replicate food, and it can replicate clothing. Well, 3D printing is kind of like the beginning of that. I mean, that's what you're doing. You're manufacturing something from something else. And if it ever gets to that level where that's what's happening, I mean, people are going to be so heavily dependent on the technology. If it goes down or it crashes or has problems, people are going to die. Like, I mean, if people are 3D printing their medicine, which I was reading an article about a 3D printer that they're using now that can build molecules for like molecule chains for making medication. So they can actually create experimental drugs using this 3D printer. And I'm thinking to myself, well, in the future, if I've got a heart ailment, I got to go to my machine to print my dosage every day, and then the DRM's fucking can't authenticate with Microsoft servers, and now I don't get my dose and I die, I'm going to be pretty pissed. So it kind of makes you wonder that if the technology keeps growing in that direction, it becomes something that we're all so heavily dependent on. is there going to be a backup system in play? Or when the servers go down, is it now like if you're a software tester, does that mean you hold everybody's lives in your hand? Now you're like a 911 dispatcher. It's like you screw up and miss a bug, like fucking 50 people die, and your manager comes in and like smacks you on the wrist for it. It's kind of weird to think about.
Don't let it happen again. This is the third time, Stevens.
Again, man. That was my aunt that died last night. You son of a bitch.
part of technology. It's part of moving forward, as a society.
To go forward, you have to. A couple people have to go backwards and fall off some stairs and stuff like that. Yeah, totally.
Now you mentioned the molecular printing.
Yes.
Do you think that something in that area could come and just completely remove the entire process of 3D printing? And change it entirely so that now we're working with devices that intelligently build things from the molecule up to the final product.
That's the scary thing is I think it's something that's entirely possible, because think about it, if they're making medication by like manipulating molecules, then it's just another couple of steps before they're manipulating the atoms themselves. I mean, and then at that point, boom, now you got a way to convert air into anything, right? I mean, yeah, anything into anything.
Yeah, then we really do have Star Trek. We've got the replicator. You can have whatever you want, and all the restaurants everywhere will go out of business.
Yeah, exactly.
Why would anybody go out to a restaurant anymore?
And now you're just going to see, every time you see somebody running down the street that's a little fatter than they should be and looking a little happier than they should be, you just arrest them for piracy. I mean, that's just
You've been pirating filet mignon and duck confit. We know this to be true.
Sir, there is no way you're living off your allocated ration. Yeah. No, it's...
Oh, man.
It's sad, exactly it's sad but true. But that's the thing is 3D printing, you look at it, and it started off being this very, very simplistic thing. It's like, let's take and extrude some plastic through a nozzle and build something. And then they keep refining the resolution, they change the materials, and then some other guy goes, wow, that's actually a genius idea. I wonder if we could take some, sugar water and some human cells and make an ear. And then next thing you know, they make an ear. And then he's like, whoa, why can't we make a heart or a kidney? Now you got a heart or a kidney. Now, granted, none of these things have been successfully transplanted to humans yet, because we've got one of those societies where it'll take 20 years before anybody will work up the balls to try it. But the fact is, it keeps going that next generation. Hell, they're 3D printing houses. Did you guys see the 3D printer that they got that's like using concrete and straw to build houses? It's crazy, but if you look at it, if you step back 1,000 yards, it looks like a MakerBot. I mean, it is. It's just a giant gantry with a freaking print head on it, and it walks up and down and prints walls. It's just wild. So if that just keeps getting refined and more microscopic, at some point you're going to end up with a print head that's like microns in size, and it's literally just manipulating the molecules at the nozzle and going back and forth at a billion times a second, and then you got anything at that point.
Well, the inkjet technology, as far as like skin grafts and that sort of thing, inkjet technology has been leveraged to lay down scaffolding that skin grafts will grow on. And so 3D printing, I mean, that same process with those types of 3D ink nozzles is going to be like the transition from 9-pin dot matrix printing to inkjet printing. Because, inkjet printers already are at such ridiculous resolutions that they are basically controlling a relatively small number of molecules of printer ink accurately. And so that with other materials other than ink is going to be crazy.
Well, it's like you look at the print head. Like I've pulled the print head out of my inkjet before and looked at it, and it looks like a flat, solid piece of metal. The holes are so small on the print head, it's like you can't even see them. And you think to yourself, you're like, how can anything squeeze through these damn things? It's because like the ink is actually like a thinner consistency than even water. It's wild how they do that. And if you think about 3D printing, all it is just adding another axis to that, right?
Yep.
An inkjet, just like I was, just like with like printing circuits on paper using like the conductive ink that they do. You print a layer, you print another sheet of paper and stack it, another sheet of paper and stack it. That's not all that dissimilar from how 3D printers work, is printing a layer, going up and printing a layer. Imagine when they get to the point where they combine the two and they somehow create an ink that can solidify and dry fast enough without dispersing, that they can just build a layer on top of a layer on top of a layer. And now you've got that resolution of an inkjet on the z-axis. But I'd imagine you printing something would probably take eons with current technology, because like right now a 3D printer, you'll be waiting around like this thing right here. That took I think about 17 hours to print.
Good Lord.
And I was printing at a relatively medium speed. I could have pushed it harder, but it's my beautiful face. I didn't want to ruin it. But it's, imagine if you were doing that at a resolution that was 1,000 times finer than that. I mean, it could take years to print that.
Well,
I think it's possible. Oh, go ahead.
It's funny you mention that because on the inkjet side of things, I remember reading an article about MakerBot was, I think it was one of the original MakerBot engineers. They were trying to find a way to compensate for the inertia of the print head gantry thing because it was just so massive. And the inkjet industry has dealt with that. There's if you look very closely at most inkjet printers, there's a very thin sort of translucent plastic strip at the back of the printer. And so it's actually got a sensor to sense where the print head is exactly. So it's not just relying on a number of steps sent to the stepper motor, as virtually every 3D printer is today, but it's actually got an encoding mechanism to encode physically where the print head is. And they're able to do that to get better accuracy and calibration and things like that on the inkjet side of things. And the MakerBot guy was like, we were looking at doing that, but it turns out Epson owns all the patents on everything on that, and it's not going to expire for like 10 years.
God.
There we go. Patents.
There's your answer, Logan. The patents ruin everything, and we're never going to have anything better than we have right now because all the companies are just going to sit on all the intellectual property and never let anybody take it to the next level.
That's why 3D printing is taking off now, is because this was all done in the 80s. I mean, the computers to drive 3D printers, exactly like what we have today, were much larger. They weren't, basically a Raspberry Pi or something like that that's built into the machine. But this technology was all patented more than 20 years ago, and the patents have expired, last year and the year before, and that's why it's taken off.
Oh, I didn't realize that, because I've seen some stupid 3D printing patents. I can't remember, but one of the companies actually holds a patent, I shit you not, for having an enclosed build environment. Literally, the 3D printers, you always see them, they don't have a closed front on them. It's because some company owns a patent for putting anything over the front of that to seal it. How do you own a patent on a box?
I believe that was
Stratus. What the patent is.
And Stratus bought MakerBot, I believe.
Oh, did they really?
I think so. Let me confirm that.
I just, you know what, that pisses me off. I'm gonna go off on a little patent tangent here. I think it's bullshit that you can patent stuff that's so vague.
Yeah.
I think I'm gonna patent shoelaces. I'm gonna patent a string that holds shit on. You can't do that.
I mean, yeah, could you imagine at the turn of the century if people were as patent crazy with minute things? I mean, it seemed like back then they had to patent things that were like, this is a mechanism that is exactly this long that does these 17 things through this very distinctive process. But now it's like, I want to patent red squares, and the USPTO is like, oh yeah, that's great, red squares. Yeah, you can have red squares.
What was
Perfect.
it, Apple that owns Apple owns the copyright or whatever for like a rectangular phone or some bullshit.
It's a rectangle
touchable surface, basically every phone in the world.
Yeah, it's a rectangle specifically with rounded edges. It's got to have those.
Yes, the rounded edges. And they probably didn't even have to specify to what degree they were rounded. It was just rounded edges.
Yeah, and then you show a jury, and it's like, that looks rounded. Oh, yeah, the patent is, yes, $1 million, $10 billion, whatever.
I'm going to patent putting food in your face, and then I'm just going to watch everybody die. That's what I mean. I'm going to patent it. I'm going to own the mechanism of transporting food to your face using an extremity.
Any extremity.
Just royalties every day. I'm just going to get from Burger King and McDonald's. It's going to be awesome.
Not just a fork, yeah. Well, people are going to start taking it intravenously, and I'll patent that. there will be no nourishment. No nourishment. We will stop all nourishment.
That was the worst
unless we get paid.
Ever. Oh my god. Oh.
Oh man. So I want to throw this out to the audience right now. We've been BSing for a little while about 3D printing in the future. And I want to know what you guys think. Let us know what you think is going to happen in 5-10 years, and then we can all sit here and watch ourselves get older, and also see if those things come to pass, and pat ourselves on the back when we're all right. Because we're all going to be right? Wendell, did you have anything to add to this? I've been directing the conversation mostly, but you know more about it than I do. You got anything else you want to talk about or chew on before we?
No, I think we've pretty well covered everything. I mean, it's a huge topic. There's a ton of things going on, and 3D printing, both in the manufacturing space and in the hobby space, are completely revolutionary and going to take over the universe. I don't know about home printing. I mean, I see people going down to the quote-unquote Replimat and doing it that way, because I don't know that it makes sense to have a 3D printer that could say print a fridge. I don't know that everybody needs that. You can just go down to your friendly neighborhood Replimat and be like, I need a new fridge. Here's my old fridge for which to use to get elements to make the new fridge.
Yep. And to be honest, it does, even from where I stand, and I do a lot of 3D printing videos and stuff like that, the 3D printing is more for like rapid prototyping, testing, seeing if things work and stuff like that. It's not practical for production. It's really not. If you figure out, you work the kinks out of it, just like I did with my 3D brackets. I had the guy 3D model brackets for my racing simulator he's never seen by me taking pictures of a ruler next to stuff. And he literally catted it up from my measurements, sent it to me. I 3D printed it. It took us 2 tries to get it to fit the frame perfectly, and then I sent it off to have it milled out of aluminum. So I'm still actually waiting for those parts. But it's that whole process. If I had to go to the Replimat every time I wanted to create one of the prototypes, that's going to cost me a lot of time because I'm going to have to like wait a day for them to open, go do it, wait for them to print it, go pick it up, bring it back home. The fact that I can print 2 or 3 a day if I need to get the fitment right, I mean, just increases my productivity. I mean, tenfold. It's awesome. So I think that's where home 3D printing is going to be strong.
All right. So last question. I'm not sure if you have it there for show and tell, but what is your favorite thing that you've ever printed?
My favorite thing that I've 3D printed to date would be the Master Chief helmet, which unfortunately is on tour with the Ultimaker folks right now. They loved it so much at Maker Faire. They wanted to take it on tour to their Paris show and stuff like that. So I went ahead and let them take that. That's my favorite thing that I've printed. My second favorite thing that I've printed is definitely Groot, because this is actually out of bronze material. It weighs a ton. This actually feels like a metallic object. I can knock you out with this right now, Logan, and it is awesome. Nice. So that's probably my second favorite print that I've done, just because it's a material that doesn't feel. It's even cold like metal. It doesn't feel like plastic at all. And so this is like a little peek at the future. It's just the fact that here in my home, from a spool of brown material, I created something that's like metal. That's awesome.
How much do you think it cost to print something like that? I mean, was it obviously additional money compared to regular printing?
Well, I got one spool of the material, which I can't remember what the length of the spool was, but it's about $50, and I could probably print 2 sets of these. So I'm going to say that each one of these is probably around $10-15 to print something like that in material once you have the machine.
Yeah, that's not bad at all.
I don't think so.
Right. Well, I think that's about it. You guys, like I said, post comments in the forum. If you guys want to see Barnacules again, let us know, and maybe we'll come up with something ridiculous and crazy next time. Next time we're up in the area, up in the Pacific Northwest, we should do something ridiculous, a skid or I don't know. We'll come up with something, but
let's do it. I'm always up for hanging out with you guys and doing ridiculous, funny shit. So bring it. Seriously, bring it.
And let us know when you're on the East Coast again. So it'll be awesome. All right, man. Appreciate it. Awesome talking to you, and we will see you on the interwebs.
All right, take it easy, guys.
See ya.